Hello everyone and welcome to Coding Card. So in this session we are going to solve one graph problem. So you can see here the problem name is connected components. So here we will be given one undirected graph, and what we have to do here is you have to find the total number of connected components, which means, for example, let me explain you here. We are given one graph. Let us suppose we a node 0, node 1, 0 is connected to 1, 0 is also connected to suppose 5, and 0 is connected to 8, and 5 is connected to 8. Also 2 is connected to 3, and 2 is also connected to 4, and 4 is connected to 3. So you can see here these are undirected graph. So you can see here the given example is of undirected graph. What we have to do here is we have to find the total number of connected components in this given graph. So what connected component means is, suppose if you are standing at any node, for example you are standing at 0, node 0, and if you are able to traverse all its connected neighbors, means each and every node along with this 0. So once this traversal is over, so that will be one connected components, means that will be one count. So for example, if you are at 0, so from 0 you are able to traverse 1, 5 and 8. So all its neighbors are being traversed. So this will be one count for us. For example, here if you are standing at 2, then you are able to traverse 3 and 4. So all its connected neighbors are traversed. So this will be another component. So there will be two components. So for this given sample, there are two connected components. For example, if you are given one more components like 6, 7 and suppose 9. Now if I stand here at 7, so I can easily traverse 6, and with the help of 6 I can traverse to 9. So this will be one component for us, connected components for us. So we have one problem over here. You can see here we have one problem, connected components count. So you will given one adjacency list of an undirected graph, and you have to find the total number of connected components. So for example, this is one sample. So this is one given sample. So this is the same graph which I explained you here. So let me explain you again from that sample. So we are given one adjacency list. For example, node 0 connected to 8, 1 and 5. 1 connected to 0, 5 connected to 0 and 8, and 8 connected to 0 and 5, 2 connected to 3 and 4, 2 and 4, and 4 connected to 2 and 3. So this is the sample, right? So how to solve this one? Very simple. We'll simply do a DFS traversal. We'll simply do a DFS traversal. For example, if we are starting with this node 0, so what we will do? We will start the traversal for each and every connected nodes, means each and every neighbors connected with this node 0. So once this current node is traversed, what we will do? We will simply add that in a visited list. Visited list, that will be a set to keep the uniqueness. After visiting this one, and suppose if we are at node 8, and again on 8 we have two approach, like we can go to 5 and go to 0. So once 0 is already visited, we need to ignore that one. So we'll keep in our visited set here. So what we will do, we will try to traverse each and every neighbor connected with this node. Okay, so once all its neighbors are traversed, we'll simply increase the counter by 1. Okay, so that means one component is found, and we'll move to the next. So similarly here, if I start from 0, all its connected components means all its neighbors will be traversed at once in one go. So in one go, all the neighbors are traversed, will increase the counter by 1. Go for the next. For 2, if I start here from 2, all its connected neighbors will be traversed in a single DFS call. So again, once Once all these things are traversed, we'll increase the counter again by 1. So we are done. Our answer will be 2. So let me explain you by code here. So what we will do, we will be given a graph. We will be given the graph. This connected components will be given to us. Our main task is to create one visited this will be a set to keep the unique node, and one is the count equal to 0 initially. Okay, now what we are going to do here is we need to traverse node by node, right? So for node in graph, what we are going to do here is, like graph is already given, we are going to traverse node by node. If node not in visited list, if the incoming node is not present in our visited list, what we are going to do, we'll simply go for DFS traversal. If node not in visited, what we are going to do, go for DFS traversal and pass this node. Okay, it means we are going for a DFS traversal for the current node, and this DFS traversal means we will write the function over here again for this DFS. What we will do is define first DFS, and this will accept a node. First of all, you have to write the base condition for this DFS. So base condition will be what? Simple. If node in visited, if the node is already present in visited, what we have to do? You have to simply return. So this DFS traversal I have already explained in detail using recursion. You can watch that video. Now this is the base condition. If the node is already present in visited, we have to simply return. Now if that node is not present in visited, then what we have to do, we have to first add that incoming current node in the visited list. So visited dot add that incoming node, means we have added that node in the visited list. Now we have to traverse all its neighbor. So for, let me write, for neighbor in graph of the node, incoming node, right? For neighbor in graph of incoming node. For example, you see here, if I am starting with 0, so currently 0 is the start point, so this is not present in our visited set as well. So what we will do, it will go for DFS node. So it will come here at line number 3, DFS node. This is also not present in visited list. Now add this incoming node in the visited list. Now after that, let's go one by one. Its neighbors are 8, 1, 5. One by one, go for the DFS traversal. DFS of neighbor. So it will call it recursively and it will traverse each and every neighbor one by one. So for the node 0, what we did, we started one by one, started with the single node for the DFS, and for this single node all its neighbors are being traversed one by one using recursion. And once the nodes are traversed, we are simply keeping that in a visited list, so that going forward you don't have to traverse again. So once this is done, what is our next task? Once this is done, we'll simply increase our counter, count plus equal to 1. That's it. And at the end we have to return this count, right? Simple. Let us run this one. So we need to sign first. Let us run this one. So you can see here it got passed. So you can see here it got passed. So how these things are working? So let me explain you one more time in detail. This is the code and this is the sample data. Right? Now let me explain you here. We have one visited set, right? We have one visited set. So we started from here, line number 13. We started from here, line number 13. So we started with 0. If node in graph, so for node in graph, if node not in visited, yes, it is not in visited, go for a DFS of node. So it will go for a DFS of node. So DFS of 0. DFS of 0, it will go to line number 3 to this function. Now here, if node in visited, no, it is not present, go for next line, add that 0 over here. So 0 is added for never in graph of node. So for never in graph of 0. So for graph of 0, 0 will be as a key, so value will be 815. So again, it will call this DFS of 8 one by one, DFS of 8, DFS of 1, and then DFS of 5. So this was in the very first iteration for this for loop. So DFS of 8. So 8 is present in visited? No. So add that one, and again here it will go for DFS of 0 and 5. So DFS of 0 is already there, 0 is already in visited, it won't call, it will call DFS of 5. We are not, we haven't reached here. It's started with 0 and it's working for all its neighbors, and one by one neighbor is connected to another neighbor. So it's working accordingly with the help of recursion. So just see here, now DFS of 5, DFS of 5, do we, for DFS of 5 it will add here 5, and after that it will go for its neighbor. So for its neighbor, if you see 0 and 8, so 0 and 8 are already present, so here nothing will be called. Now the very first for loop neighbor 8 is done. Now it will go for the next one. So for 1, DFS of 1, it will first add here 1, and since it's never 1 never is 0, it's already captured, so nothing will happen. Now it's go for DFS of 5. So DFS of 5, 5 will be 5 is already added, and also its never is 0 and 8, so nothing will happen. So for the first iteration we are done. This was our very first iteration for the DFS of 0. So these were the connected components, and here value will be again, we will come here, line number 15 got over, line number 15 got over. Now next is count plus 1, so count will be 1. Now next, go for the loop. Next is we started with 0. Now we started with 0, so 0 is done. Now 1 is already present in visited list. Here if you see here the condition, line number 14, if it is not in visited list, then it's going for DFS of node, since it is already present, because it was already covered in the previous call. Again for 5 it's already present, 8 is also present, so we are done here. Now it will go for DFS of 2. Since 2 is not present, it will go for DFS of 2. Now again, DFS of 2. So we are here at line number 15. DFS of 2. So this node is not present in visited. So what it will do? It will first go and add that one in visited. So add this one. 2 is added. Now it's never. Never are 3 and 4. So for this 3 and 4, DFS of 3 and DFS of 4 will be called, right? So again this 3 is not present in visited, so what will happen is 3 will be added, and after that its never will be called. So 3 never are 2, so 2 is already present, and 4. So for 4 it will be DFS of, so for 4 there will be DFS of 4. So again 4 is not present, 4 will be added, and its never are 3 and 2. So 3 and 2 are already present in its never are 3 and 2. So these are already present, so nothing will happen. These are already captured. So this part we are done. Recursion is already called. Now DFS of 4. 4 is already present, so nothing will happen. So DFS of 2 is done, means line number 15 DFS recursive call is over. This is over. So count. So count will be increased by 1. So 1 plus again 1. So will be 2. So now this one is done. Now again go for the next node. Next node is 3. This is also present in visited, nothing will happen. 4 is also present. So this loop is over. At the end we are returning count. So count is 2. So answer is 2. So I hope you understood this problem in a very simple way. So if you have learned something new, please do like our videos and subscribe to our channel Coding Card, and stay tuned for the next video.